Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred. We're going to keep trucking along with Unit 9. We're going to talk about mini lesson number 3, remote, interior, and exterior angles of triangles. Okay? You should be able to explain how to solve for missing angles using the rules that I give you here at the beginning of these notes in this mini lesson by the end of today's lesson. Okay? We're going to go and get started with the notes right now. You see 3 vocabulary words there on the top. We're going to talk about those vocabulary words and what they mean. Try to write definitions for them and maybe draw a diagram here for you too. Okay? Whenever you create a triangle, it's a 3-sided shape. You can always draw an extension of one of the lines of that triangle and create an exterior angle. We'll talk about a couple things that are created when you do that. The first thing is kind of a review from the previous mini lessons we've had. Adjacent angles are those 2 angles that share a common side and a common vertex, much like you could say maybe this angle and this angle right here are adjacent because they do share this common vertex and the common side and common vertex right there. Those 2 angles are adjacent. Whenever you create that exterior angle right here of a triangle, you do create what's called an exterior angle when you form an extension of a side of a triangle. So this angle right here would be considered an exterior angle to that triangle because it's not inside the triangle. It's made with an extension of one of the sides. And it forms an adjacent angle with one of the interior angles, and it's called an exterior angle. Okay. Whenever you form that exterior angle, you form 2 non-adjacent interior angles, and those are called remote interior angles. Okay. This is super important. When you create that exterior angle, this is the exterior angle, you form what are called 2 non-adjacent interior angles. So this guy right here would be a non-adjacent interior angle, as well as this guy right here. So this point and this point, those 2 angles are non-adjacent exterior angles to this son of a gun right here, the exterior angle. They're called non-adjacent because they are not next to the exterior angle. Those 2 non-adjacent angles are formed. Okay? Those are the 3 vocabulary words you're going to use. You can use that information to help you, but you can really use some things we've already learned to help us with examples number 1 and number 2. Okay? I'm going to work through example number 1 and number 2 using strategies that we already know, and then we're going to look at the table in the middle and see if we can find any odd similarities. Okay? If I was trying to solve for x right here, okay, instead of solving for x from the beginning, let's try to solve for this guy right here, this angle. Okay? That'll help us solve for x because we know that x and 65 degrees or x and that inside angle are going to be supplementary to each other. Let's figure out what this angle is on the inside of the triangle. If you do 60 plus 55 is 115, and we learned in mini lesson number 2 that the sum of all the interior angles of a triangle was 180 degrees. If I take 115 and subtract it from 180, I get 65 degrees. That tells me that that interior angle, the third angle inside the triangle, is 65 degrees. When I drew that extension, I formed a straight line between this guy and this guy. All I have to do is solve for the supplement of 65 by subtracting 65 from 180. When I do that, I get 115 degrees. I just found my first exterior angle of a triangle by solving for the third interior angle of it and then subtracting from 180. Okay, example number 2, I'm going to have to solve it a little bit differently. I'm going to have to solve for this adjacent angle first, the adjacent angle to this exterior angle first. I know they are supplementary. They add up to 180. So when I do 180 minus 92, I get 88. That tells me that this interior angle, V, the one that's adjacent to the exterior angle, is 88 degrees. Okay, now I know 2 of the interior angles of the triangle, 88 and 50. I know they all had to add up to 180. So I did 180 minus 50 minus 88, and I got 42 degrees there for the third angle inside the triangle. Okay, what we're going to do now is we're going to fill out the little table there in the middle, and Ed Puzzle might ask you a couple questions along the way while we do that. If you look at example 1, you got 2 remote interior angles. Those are the two non-adjacent interior angles of the exterior angle. I know I'm saying lots of words, but the two remote interior angles for the first problem up there would be this guy and this guy. Those are the two remote interior angles. They're not adjacent to the exterior angle. Their measurements are 60 and 55, like we said already. Okay, and the exterior angle there, which we solved ourselves using rules we already know, was 115 degrees. Look at example 2. The remote interior angles to the exterior angle would be this sucker right here and this sucker up here. They're not adjacent to the exterior angle. Their measurements were 42 and 50, and we found we were already given the exterior angle. In that case, it was 92 degrees. Okay, look at that chart. Look at that chart. What do you notice? What relationship do you see between the measures of the remote interior angles and the exterior angle? Tell Edpuzzle what you think. The truth is that the two remote interior angles of a triangle will always add up to be the same as the exterior angle of a triangle. That's a rule that we can certainly use for some of these math problems to help us out. Okay, it's a fairly important rule, and we'll use it lots of times. Okay, for example, in triangle PQR, the measure of angle Q is 45 degrees, and angle R measures 72 degrees. Find the measure of an exterior angle at P. Here's what happened at this lovely triangle right here. We've got one angle that's 45 degrees. That's this guy right here. And we've got one angle that's 72 degrees. That's this guy right here. And we also know that we have an exterior angle at P. That means that there's been a line drawn from P out of the triangle, and we are trying to find the measure of that exterior angle right there at P. Okay. The truth is, we already know these two remote interior angles, the two non-adjacent interior angles, are 45 and 72. I know that if I add those up, based on the rule we just talked about, those have to equal the exterior angle. It's 117. If you still don't trust yourself, take 117, subtract it from 180. That would tell you the other interior angle of the triangle would be 63. And the only way to get from 63 to the other interior angle would be to subtract it from 180, making it 117. Okay? The two remote interior angles of a triangle have to add up to be the same as the exterior angle. You're going to work on number 2 and number 3 there on your own. Okay? Thank you for watching. Please keep all hands and feet inside the ride at all times. Let me know if you have any questions when you get to my station. Thank you.